Hello everyone, today our topic is about magnetic field, okay? So let's move into the first slide, and here you can find that there's a magnetic field, and here is a magnet, right? And you can find there are different curves around the magnet, right? So just say very similar to like the electrical field, right? We knew that the positive charge will give out the electric field, and the negative charge will receive the electric field, right? So we can say, oh, here we just consider the north pole very similar to the positive charge. So it will release the magnetic field outside, okay? And the south pole will receive the magnetic field, okay? So how to determine this? You can using a magnet and put here and to make it as a pin, and the pin will rotate, and you'll find that there is this direction. Okay. So it's very similar to a compass, right? They're using a compass to find the direction, okay? So it's like this way. And if you're putting the magnets on some metals, like uh, like here are many small metal sand, like in this way. And if you put in as magnets right here, and it will gives out like here like this, different curves like this way. Okay. So we can say, oh, here is a distribution of magnetic field. Okay. So we can find that, oh, maybe that ends for North Pole to release the magnetic field and the South Pole just to receive the magnetic field. Okay. Here is for the first part. And for the second, you can just using the compass to find the direction. And maybe you can use the compass to show the north direction, and it means that here is the south direction, right? So please remember that the north direction or the north pole just towards the compass south direction, because south is attracted by the north pole, right? Okay, so like this way. Okay, so we can set for the Earth, we said before, like Earth is a very big magnet, right? And its geography north means magnetic south. Okay, and its geography south means magnetic north. Okay, this is for the magnetic field patterns. Okay, so here you can find if you put in two magnets together, if they're the same poles like N and N on the right figure, you can find that they are just have a like a repulsive force with each other. So the magnet field just very similar to like two positive charge like this way. Okay, like they're releasing the field like this way. Okay, not very difficult. Okay, this is for this right figure. And on the left figure, you can find that your N pole just release out to the S pole, okay? Just from N north to the south, like this way, okay? So we can say, oh, there's not very difficult. You can using the north before, or you can trace back to the electric field part and to just remind it, okay? So we have several conclusions. The first conclusion is that N pole release and the south pole receive, right? This is for the first property. And for second property, we said, oh, here there's no intercept with magnetic field, okay? There's no intercept between each magnetic field, okay? The second property. And for the third property, we can say, oh, if the lines are very dense, that means they have a very strong magnetic field, right? So we said the density of the lines distribution just distribution just gives us the result that it has a very strong magnetic field, okay? So this is a very similar property just as the electric field. If you have any question, please just trace back to the electric field part and try to make a review, okay? This is for the third property, okay? And I guess this is not very difficult for you to draw the line if you just remember the two graphs right here, okay? So like here, we can also say, oh, Earth is also a very big magnet. And you can find this is the North Pole, and here's a magnetic south, and here's a South Pole, and here's a magnetic north. So wire compass always show north as its right direction, because north represent for is attracting by the magnetic south of the Earth. So it just shows the direction of the geography north, okay? Like this way, okay? So here, scientists are trying to find a North Pole on the Atlantic. Okay, because right here, we knew that the South Pole have a magnetic North Pole, so you can try to find the North magnetic pole at the South Pole. Okay, it's very difficult to understand, but just like they have the reverse direction as the magnetic field, and for the like the North Pole and South Pole on geography meaning. Okay, so here's the exercise. Please trying to find the answer right here. Okay, not very difficult, yeah. We can choose A because here we have a very high density at A. You can find lines are distributed very close to each other. So we can say, oh, at A point, it has the strongest magnetic field. Okay, so finally we choose A as our final result. Okay, so this is our today's lesson, and I hope you can just make a review of the magnetic field and its distribution. Okay, very similar to the electric field. Okay, so see you next time. Bye.